Anna Franz, a biochemist at the University of Bristol in Britain, was studying how a fruit fly's immune cells respond when the insect is wounded. Under the microscope, she noticed cloud-like shadows moving toward a lesion. Because of their size, she suspected the shadows might be fat cells, which can be 5 to 10 times bigger than other cells found in fruit flies. But how could these cells, which are conventionally believed to have no ability to move themselves around, make such an unlikely journey? And why? Biologists have long believed that fat cells lead sedentary lives, unable to move themselves around the body once they get settled. But new research suggests that fruit fly fat cells have greater mobility, and are therefore more helpful in an emergency than previously thought. And that could have implications for how we think about fat cells in other organisms, including ourselves. Dr. Franz and two colleagues used lasers to make small lacerations in the thoraxes of fruit flies, where very few fat cells reside. To their surprise, they found that a handful of fat cells not only arrived at the wound within minutes, but performed vital functions once they got there. First, the fat cells used their mass to plug the wound, then pushed harmful debris to the edges, where immune cells were waiting to dispose of them. It's like a cleaner, sweeping the stuff to the side, said Paul Martin, a co-author of the study, which was published Monday in the journal Developmental Cell. Then, the immune cells are all hanging out at the edge clearing the debris. So it's a collaborative effort. The fat cells also produced an antimicrobial substance that may help stave off infection as the fruit flies heal. Though the fat cells did seem to be moving themselves, their means of locomotion was unusual. Cells typically move by using tiny filaments that help them push and pull off other objects. But the fat cells appeared to swim through fluid by flexing and relaxing a pair of proteins, actin and myosin, which are found in muscle fibers. Imagine you've got a partially blown up balloon in your hand, and you squash part of it so it escapes upwards out of your hand, Dr. Martin said. The cell was squashing itself forward. Read more. Trillions of flies can't all be bad. To confirm that the actin and myosin were facilitating the movement, the researchers created genetically modified versions of the cells in which those proteins were inactive. Those cells were not able to move on their own. How the cells know to go to a wound is still not clear. But the researchers did rule out the most obvious explanation, that they are summoned to the wound by immune cells. That's definitely not the case, because if we delete immune cells from the fly, the fat cells still go to the wound, Dr. Martin said. Other studies have noted that fat cells might assist with tissue repair, and there is growing consensus that their role goes beyond providing insulation and energy, as was once believed. Read more. Focusing on fruit flies, curiosity takes flight. For now, Dr. Martin and his team are focusing on whether fat cells in other vertebrates are also capable of locomotion. A finding that could generate excitement among weight loss professionals. There are quite a lot of people on this planet that would like their fat cells to move from one place to the other, he said.